Hello to everyone. My name is Gentjan and I'm shortly introducing our work presented at the conference as poster. First of all, I would like to introduce with position sensing. The position sensing is built in a printed circuit board, as you see in this figure. It has a set of coils, a receiver and transmitter, a target that it can be a copper, and our sensor IPS 2550. And some additional passive component. It can measure a rotation, an arc motion, linear motion, and also some multi-period and multi-target. For a better explanation, let's see an example. When the metal target is rotating, a full mechanical rotation, it is giving as an output of the sensor a sine and cosine, full period. By using arcotangent, it's possible to calculate the absolute position of the target. So a typical application is an MCU connected to a sensor, where the MCU, the microcontroller, is reading the sensor analog output. So according to the automotive functional safety standard ISO 26262, one of the requirements to achieve the automotive safety integrity level as called ASIL, is the satisfaction of the hardware metrics like SPFM, LFM, PMHF. So the main tool for achieving these metrics is the implementation of safety mechanism. The safety mechanism are classified into groups: internally the sensor, so integrated, and externally, so implemented on the MCU by monitoring the output, or by only monitoring the output of the sensor. So for that, we built a Simulink model where an algorithm was designed, the so-called magnitude ripple check. The Simulink model was used also for validating the algorithm and also for simulating the so-called single fault failures. Everything was developed following the standard ISO 26262 that says that the verification of safety mechanism is done by fault injection. So the magnitude ripple check is, as you see in this formula, defined by only observing or monitoring the magnitude ripple check. Some additional correction of this algorithm are done in case of a phase shift occurs. So let's go to a typical application that we call fault case number 1. An amplitude mismatch of 11.1% is applied between sine and cosine signals that are at the first two channels of this figure. As you see on the third one, with the green color, is the magnitude signal, and on the last one, there is the error calculated from the amplitude mismatch that is equal to 3 electrical degree, plus minus 3 electrical degree, and in the blue color is the error estimated from the proposed method that is also 3 electrical degrees. With that, we can conclude that the estimated and the calculated are identical. That means that our method works correctly. With that, I would close my presentation. Thank you for following our video, and I hope to see you in our poster presentation. Thank you.